Hi everyone. This tutorial is going to cover how to use IndexedDB. IndexedDB is a tool that's available in most modern browsers to save uh, fairly large quantities of information in the user's browser on the client side so that it can be retrieved and searched quickly to make your web applications or web pages potentially faster and certainly give them the ability to load even while offline. So before we start showing how the code works and how to use IndexedDB, we'll begin by talking a little bit about why you might choose IndexedDB over some other choices like local storage or session storage, for example. We'll also talk about some basic database terminology in case you're not familiar with that. Concepts like a database itself, what an index is, a transaction, a schema, concepts that you would want to understand just at least the gist of before you begin using IndexedDB. And they're the same concepts that would apply to whatever database that you choose to use in the future or any database you've used in the past. So if you want to skip, if you're already familiar with that and you want to skip that part, we'll have a timestamp in the comments and you can jump ahead to the code. Otherwise, stick around for the next part and we'll cover those topics. So before we start learning on how to use IndexedDB, we should take a moment to explain sort of what IndexedDB is and why you might want to use it. So it's a bit of a niche tool. It's not something that you're going to want to use in every application that you make. Many times it's overkill for what you want to do, and many other times it doesn't have enough options available to do what you want to do. In which case you would reach for a real permanent database with your own backend server and things like that. What it does excel at in particular is storing large quantities of data on the client side in the browser that can be maintained when the browser is closed and easily and quickly searchable. So if you're building particularly like a mobile app or a web tool or something that you'd like to keep working even when the internet goes offline or the person is offline, then IndexedDB serves that purpose quite well. If you're just looking, to make a little app that takes some data from the user, say like a to-do app, as people often like to create, where they create a new to-do list of something that they want to do and add it and have that still be there when they refresh the browser or they close the browser, then you might want to look into something simpler like what's called local storage or session storage. Those allow you to store up to a few megabytes of data inside the browser to be there next time you come back, even after the session was closed. IndexedDB in particular is specifically good at for data where there's a larger quantity than that and data that's going to want to be searchable. Before we get into using IndexedDB in our app, I just want to get some basic terminology out there. So in case I say something that isn't familiar, you understand at least the gist of what we're talking about. So when we say database, a database in general, a database is just an organized collection of data that's searchable. So it's a pretty broad definition, and it's intended to be that way. A folder on Windows with a bunch of files that you can search for, that's its own, that's a database in its own way. A text file with data that you've organized in a certain way and you use the Control F function, that's it's a text file, but it's also a database with searchable data. So these are these are stretches, but you get the idea. In practice, when people say database, they're usually talking about a large storage space of organized data that can be searchable typically remotely. So if you're searching a product database in an online store, that's an example, or a personnel database in an employee system. And when we talk about database, the structure of the data, so the type of data that's stored and the characteristics and the information about that data, that's called the schema. So when you hear schema, it's essentially the shape of the data that's being stored in the database. So with the person example, if you had a database of people, you could come up with a million different things to describe about people. But if that database only stored the color of shirt that they wore and their name, then the schema would be color of shirt, the name would be their name. And then typically with the schema, you also describe the type of data. So the name would probably be a string, and the color of shirt would, also be a string. Moving on from that, an index you'll hear a lot. An index is exactly what you think of when you hear index and you look in a book. It's basically something that is designed to improve the searchability of data at the cost of taking up space. So when speaking digitally, an index would be something that you create, which takes up some additional space on the database, but it makes it hopefully easier to search through that data. So, for example, if you're looking at a book, the index in the back usually goes by subject. You look up a textbook, a math textbook, and you want to know about algebra, you go to the index under A and find it and get the page number. So a digital index works the same kind of way. If I have a database of people and I create an index on the color of their shirt, then it will store information on that database related to the color of the shirt of all the people in the database, and make it very easy and very fast to search by the color of the shirt, at the expense of taking up a little space and at the expense of taking a little bit longer to add new data, because not only do you have to add the data to the database, you also have to update the index, assuming that the person that you're inserting has a shirt. A transaction, if you hear transaction, so when you work with databases, you do operations, queries, get data, insertions to add new data, updates to change data that's already there. What you'll find when you start working with more complicated data and more complicated databases, you end up in a scenario very frequently where you want to do a number of different operations that are related, and if any one of them has a problem, you want to cancel all the operations. So a really easy and common example of this is anytime you're dealing with like a financial transaction. So if you were building a database for a bank and you wanted to have the pretty common operation of moving money between accounts, your first database operation would be to, say, remove money from account A, and the second one would be to add that money to account B. And if you have for any reason the database isn't able to add that money to account B, you certainly would want to cancel the removal of money from account A, otherwise it would disappear into nothingness. So transactions allow you to batch database operations together and say, if one of these doesn't succeed for any reason, I want all of them to fail. And I know that if one of them succeeded and the transaction succeeded, that every operation that was involved succeeded. We won't talk about it much in this tutorial, but if you hear it, a cursor is simply pointing to a point in your query so that you can query for data kind of more like a stream or one at a time. And I apologize if I'm butchering this definition, but commonly, and where you'd use it in IndexedDB or in a lot of databases, is that if you're querying for huge amounts of data, like a million records, and you just want to be able to cycle through them one at a time, if you queried them all at once, you get a million records back on your server and whatever app that you're using, and that might take up a ton of memory space. Your database is designed to have that kind of memory space. That's what it's optimized for, but your app might not. So rather than querying all that data and having your app go through it one by one, you would use what's called a cursor. So the database would return all that information, have it ready for you, and simply provide you with sort of a lookup key that says, all right, you're on row number 2 right now. Here's row number 2. You done with that? Great. Advance your cursor. Here's row number 3, row number 4, yada, yada, yada. So that's what a cursor is used for, to help optimize the way that the database works and not overload your application that you're working on with more data that it can handle. So with those terms out of the way, we're now ready to move into using IndexedDB in a little JavaScript app. So the first thing we're going to do is we're going to create an index.html file that we can host so we can see our JavaScript file and we can check out the work we've done using IndexedDB. So I'm going to create a new file, index.html, and I'm just going to use one of VS Code's built-in templates. I hit the exclamation point, I select the first one here. You can write it out yourself if you want, it doesn't matter. So the most important thing is that I need to import a JavaScript file. So I'm going to use script tag, and I'm going to call it just script.js. And close my script tag. So when I load this HTML page, it's going to go looking for a script.js file in my root directory. So that's what I'm going to create now. Create new file, script.js. So this is where we're going to start using IndexedDB. So the first thing that we need to do if we use it is we're going to need a variable that has a reference to index.db. Now, depending on the age of the browser that you're using, it's possible that it can go by a number of different names. So we have just a little blurb here. And what that's going to do is it's going to try all of these different APIs, depending on the browser you're using, and it's going to grab the first one that it finds that exists. So it'll start by checking for window.indexedb, then Mozilla, IndexedDB, WebKit, etc., 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 each time until the final one. And if it doesn't find any, then it just means that person's browser doesn't support IndexedDB, but we're going to assume it does. So next, now that we have a reference to index.db, we're going to open a database. So what we're going to do in this tutorial is we're going to make a small database with some different examples of cars inside of it. So cars are a great example because you can use a lot of properties like the color of the car, the make, the model of the car, all that kind of thing. So it's a good example of something that you might use in real life, and it serves well to show off some of the different features. So we'll begin, and we'll drop this here, and what this is going to do is it's going to make a request to open index.db and open up a database. So what I have here is a string, and that's the name of the database that we're going to use. And this is a string that I chose myself. You can call it anything that you like. But the next time that we open it and the user opens the browser, it's going to try and open a database called cars database. And if it doesn't find it, it's going to create it. And if it does find it, then it'll open the existing one that we made. The second value here is the version number of the database. So what you can use this for is if you're working on a product, say a cars database, and over time you decide that you want to upgrade the structure of the database or change the way that it works, you can increment that number to 2, to 3, to 4, whatever you like, and that will tell the person who's running your app in their browser that it needs to update the structure of the database and run your upgrade needed function that we'll get to in a second. So the first thing that we're going to do quickly is check to see if there was any errors. Before we continue any further, we're going to run the onError method that exists whenever we create a request. So if we create the request and for one reason or another there's an error opening the database, we're not going to be able to continue any further, but we want to let the user know that an error happened. So we'll just run console.error, an error occurred with IndexedDB, and we'll log the error event to the screen, and that'll give them the information they need to figure out what the error was. Format that. Next, we're going to call a method that exists on the request called onUpgradeNeeded. It's a bit of an odd named one. Basically what it is it's a function that gets run whenever a new database is created or an existing database version number is changed. So this function is going to run the first time that we create this. And what it's going to do is it's going to give you the opportunity to create the structure, the schema of the database, and set up the information of basically what the shape of the database is going to look like. So our upgrade needed function is going to look like this. So request on upgrade needed is a function. What it does is it takes the result of our request, stores it into a database variable. So what this variable has is a reference not to IndexedDB itself, but the result of our open request. So that's going to be our cars database right here. That's stored in this variable. Next, so that's the database. The database itself doesn't actually have any information or any place to store any information yet. So what we need to do is create what's called an object store. And if you've worked with other databases before, if you've worked with SQL, this would be similar to tables. If you've worked with Mongo, it would be similar to collections. IndexedDB calls it object store. So we're going to create a new object store, and that's where we're going to store our cars. And we need to provide it with something called a key path. And the key path is equivalent to like a key or a primary key. Typically, in databases, you'll have a key called ID, and that's simply a unique number or string, a reference value that you can use to refer to the entry, or that, say in this case, that particular car. So if we were talking about cars in real life, a unique ID would be the VIN, the vehicle information number. So that would be something that you could use as the key. Next, we're going to create an index. And at the beginning of the video, we talked a little bit about what indexes are, so I won't repeat that. But there's a couple of indexes we're going to make. We'll make an index on the color of the car so that we can easily look up cars, not necessarily by their ID number, but we want to be able to say, let's see all of the red cars, let's see all of the blue cars. And that won't be unique. Obviously, there's no reason you can't have 100 black cars in your database. And secondly, we're going to create what's called a compound index. And a compound index is just a combination of more than one keys to make up an index. So this is going to be an index that combines both the color and the make of the vehicle. So if we want to be able to search, say, all red Toyotas or all gray Mazdas, then this index would give us the ability to run that search and presumably make sure that it runs quickly. And again, that's not going to be unique. There's no reason why you can't have multiple cars of the same make, of the same color. So this defines the shape of our database, particularly the object store of our cars table. So once we go to start entering information into that, we're going to want to make sure that the cars that we add have at least a minimum of these properties. The ID, which we're going to try and make unique, the color of the vehicle, and the make of the vehicle. And these are all going to be stored as strings. So next, we're going to have the onSuccess function. And this is where our operations are going to occur. Normally, you may not necessarily run all your database operations like your inserts and your lookups and all that in this function, but for the purpose of this demonstration, that's where we're going to put them. So I'm going to do this one kind of one piece at a time to make sure you understand what each line does. So we're going to add an onSuccess function to our request method that will run, presuming that we don't get an error, and it will run after the onUpgradeNeeded method, which again only fires the very first time that we open a brand new database or when we increase the version number. So our success function, similar to our upgrade_needed, we're going to do the same thing. We're going to need a reference to our cars database. So that's the result of the request. The other thing that we're going to want to do is we're going to need to create what's called a transaction. So a transaction, as we talked about at the beginning of the video, is something where we take a bunch of database operations and we add them to our transaction, and then when the transaction runs, they all occur at the same time. And if any one of them fails, all of them will fail. And that's a good thing, presuming that you set up your transactions properly. Next, we're going to get a reference to our store, the store that we created originally called cars. So the way we do that, we say store equals transaction.objectStore, and we look it up with the name of the store. So look, object store cars matches the one that we created here. Next, we need to get references. If we're going to use them, we want to get references to our index, and that will let us do the lookups that we want to do on that index. So a color index will take an index from that store, again, based on the same name that we created up here. And our make and model index, which we look up with the same name that we created up there. So these will allow us to run our queries against those indexes that we created. Now at this point, we're going to add some data to the database. So how can we do that? So we use the store, and on the store, we use a method called put. So that would be similar, again, in SQL, it would be like insert into. If you're using Mongo, I'll try and remember this one, it's create one, I believe, is the equivalent method in Mongo. So in our case, it's the variable that stores the store using the put function. So I got a few of them here. We're going to put each of them has been given sort of an incremental ID to differentiate them. We have 4 different vehicles. We have a red Toyota, a red Kia, a blue Honda, and a silver Subaru. And you can see that each one of these makes sure that we use the color and the make properties that we defined in the indexes that we created up here. And there's nothing that forces you to use those. You could leave one off, you could add additional one. But once you start doing that, you sort of start getting away from the concept of using a database, because if you don't have the ability to query for those properties, you could say that maybe some of them you don't necessarily need it. You might just want to be able to query for cars that are red, but get all the information related to them. So if that were the case, then you could add extra properties here, maybe like number of doors, whether it's manual or automatic. I used cars as an example. I'm not exactly a big automotive person, so my examples you could probably come up with some better ones, but anyway, you get the idea. You can add as much additional data as you want to, but if you want to have that data to be searchable in your database, you want to make sure those properties have an index associated with them. So now that we've added this data to our IndexedDB database, how can we query for it? So the way that we do that, we start with store.put, is we make a query using the store.get method. So the get method by default is going to do a lookup on the key path. So this one, it's going to be extremely fast. It's going to know, because of our indexes, it's going to know exactly where that entry is, and it's going to get it right away using the index. The downside is that in order to get an item by its ID, you have to know what the ID is. So you may not necessarily off the top of your head or wherever you're working in your app have access to the ID number for that entry. So this is an extremely fast lookup, but it's also not necessarily a convenient one. So let's look at something that might be more useful for use within your application. Let's say that we want to look up all the cars in our database that are red and leave behind the ones that aren't. So that query would look something like this. We'll call it color query. We'll use our color index. So here we're using the index that we got that indexes our car's color. We're going to say get all, and get all means we're going to get, rather than the first result that we find like get does, get all will get all results, and it will use the values that match up with our index. So it's going to look up color. So we're going to be looking up all cars that are the color red. And it takes that as an argument of a string array. And then lastly, our make and model index we can use like this. So we run another query. This time we want to query by make and model. So we use the make and model index that we have. We're going to want to just get, rather than all of them, we've decided this time to just get the first one that it comes across, where going in order, following the same order of the index that you created for color and make, blue for color, Honda for the make. So what this will do is it's going to find the first entry in your database for a blue Honda. If there's more than one of them, it will just return the first because we use the get method rather than the get all method. So finally, those queries occur, but like all database transactions, when you're working with a real database, there is obviously going to be a network delay. So using the same kind of API you would with a real database, any queries that you run, you'll have like an on success function, an on error function, similar to when you open your database. Any action that you take that can fail typically uses an API like that. So each one of these queries that we do, once it's completed, presuming that it ran successfully, even if it didn't get any results, that's still a successful run, it's going to run an on success function. So we can define what that function looks like. So each one of them is going to look the same. So we'll take all three of them and we'll look at them all three of them at the same time. For our first query, on success, we're simply going to console.log the result, and we'll put it next to a little string that says ID query so that we can identify it when we see it in the console and compare it to the query that we ran. And these two are the same thing. The color query, put a little label on it, and then print out the color query result next to the label. Color make query, print out the result of the color make query next to the label. If you've never used console.log in this way before, you can put as many arguments as you want to console log and it will place them next to each other. So doing this is kind of a convenient way to put a label beside a variable value so you know immediately where it came from. And then finally, nothing else really need be done, but because this is everything that our little program is going to do, once this is finished, there's nothing left, so it's always good practice to close our connection to the database rather than leaving it open. So that function is available to us on the transaction variable that's had our store, our cars store on it that we opened at the beginning and created that transaction. Once that transaction has finished, so that transaction is what's going to run these three queries. And again, if any of these failed, the transaction would fail, which means all of them would fail. So we rely on the fact that all of them are going to be successful. If that's not something that you want, that's fine. What you do is you create multiple transactions and group the ones that must succeed together in a single transaction. And if there's something that's independent of that, and it's okay if one fails and not the other, then you put that one into another transaction. And just be aware that with IndexedDB that there is a time cost associated with transactions. It runs very, very, very quickly, doing many operations, inserts of data, updates, things like that. If you batch them all in a single transaction, once you start spreading them across a lot of transactions, you can start to see slowdown. I mean, we're talking like thousands of inserts across thousands of transactions would probably take a few seconds, which is quite a lot in a web application standards. So be aware of that. So try to minimize the number of transactions that you do, and you'll find a much better experience using IndexedDB. So I got a bit off track there, but we wanted to, once the transaction is complete, similarly that's a function, and in that function we simply close the database, and that's all we do. So all of this has occurred inside the on success method of our request. So we need to close that function there. Just hit the little auto format button, make it nice and clean. We'll save that. And that's pretty much the extent of the, let's say, minimum viable, the MVP of the creating an IndexedDB example, showing most of the main features that you would probably use regularly. So let's test out to see how this code works and make sure that everything is set up properly. So all we really need to do, we already created our index.html file that loads the script file. So we just need to host our index.html file and check the console for the results of our queries. So you, I'm sure, may have your own way that you prefer to host web apps. I have the VS Code live server extension installed, which I find just to be the fastest, most convenient way if I'm just quickly wanting to host an HTML file. So with the live server extension installed, you can just right click and say open with live server, and it will pop up here. We don't see anything, which is okay because we didn't put anything in our index.html file, but we can verify that it's running by looking at the console. So if I open up the console, I'll zoom in here. We can see the results of our queries. So let's make sure, I'll do this there. Let's make sure that the data aligns with what we were expecting. So the first one, our ID query, we queried for the object in our database with, close this here, with ID number 4, which is the key path. So that should be a silver Subaru. So we see, yep, that's what it returned. And this here on the success of our ID query is where it was logged. For the second one, we used our color index to get all of the red vehicles. So that should have got a red Toyota and a red Kia. If we look here at our color query, the first object in the array and the result that we got back, it's a red Toyota. The second is a red Kia. That's great. And last, using our compound query, the make and model index, we were looking up a blue Honda. And here we see that the result of that is a blue Honda with ID number 3, just as we expected. So all of our queries that we ran returned properly. So that's great. If you want to see your actual data stored in your database, the browser actually has a really handy tool for doing that. Now I am using Firefox. Chrome works almost the same way. I can probably pull it up in a moment just to make sure that everybody can see it. But in Firefox, with your DevTools open, which is the F12 button, if we click on storage and we go to IndexedDB, I'm going to close the console here, and we select the domain that we're on. If you look, you have cars database here and our store, cars store. You can see really easy to view the data directly in the database using the storage tab. So for Chrome, I think I have Chrome on here. If I go to this same localhost 5500, I'm going to open up my DevTools F12 as well. So this is Chrome. We're going to, on the tab, it's application storage. So just a little bit different. Firefox is just storage. Chrome is application storage. Zoom in here to make it easier, but almost the same interface. IndexedDB, cars. Oh, like you can even look at your indexes. So that's pretty cool. Here's all the values, just the raw values in the cars database, and our cars color index, and our color and make index. So that's a nice little feature there to be able to look at the data with the index. So you can use this to store data for your web application however you like. So a lot of larger, more complicated web apps tend to take advantage of IndexedDB to save a large amount of information that needs to be queried quickly, so that while you're doing things like searches, using the search function, you can load it basically instantaneously, assuming it's not too large. And then whenever changes are made, those changes can be made directly on the client in IndexedDB, and you can write some functions to synchronize it with your actual database on the back end in case the user clears their private data, and that'll wipe out anything that's stored in IndexedDB. So it's not meant as a long-term storage, but it's really, really handy for storing data, at least in the short term, locally, to make a better user experience for your web apps. So I hope you found this helpful. If you have any questions, please feel free to leave a comment. Have a great day.